Welcome to this video on interactive Arduino. We will learn how to make an LED blink with a button, focusing on digital inputs, outputs, and the internal pull-up resistor. The goal is to have the LED stay off normally and blink continuously when the button is held. We will use an Arduino board, LED, current limiting resistors, a breadboard, and a push button. The logic involves reading the button state, deciding the action, and controlling the LED. Here is the circuit diagram. A 220 ohm resistor and a push button are connected between digital pin 9 and ground. An LED and a 200 ohm resistor are connected between a digital pin and ground. One problem with direct wiring is called floating pins. If you hook the button straight to the pin without a resistor, background static electricity can make your LED blink randomly, as if it's possessed. The solution is the internal pull-up resistor, activated using input_pull-up. This feature uses tiny internal resistors to automatically feed 5 volts to our pin when the button is untouched, preventing random static noise. The pull-up resistor inverts the logic. When the button is unpressed, the internal resistor pulls the voltage up to 5 volts high. When pressed, the pin connects directly to ground, LOW. Therefore, we look for a low W signal to confirm the button is pressed. In the setup, we use const int to lock our pin numbers. We define the LED pin as an output and the button pin as input_pull-up. This magic command turns on the internal pull-up resistor. The if/else decision asks, is the button currently being held down to ground? If the button state is LOW, the code triggers the blinking sequence. If not low, meaning it's high, the else statement ensures the LED stays off. This scene illustrates the if/else decision path and the resulting action on the circuit. LO triggers the blink sequence. High turns the LED off. The blink sequence has 4 steps. Turn the LED on, pause for 200 milliseconds, turn the LED off, and pause again for 200 milliseconds. As long as the button is held, this rapid 4-step sequence repeats continuously. In summary, we used input_pull-up to simplify wiring, inverted the logic to look for LOW for a button press, and used an if/else statement to control the blink cycle. A challenge for you is, how would you change the code and circuit to make a second LED turn on when the first is not blinking?